Alright, let's take a look at 1.1.1 Sequences, a quick guide to all things sequences on the HSA. So to look for, we're going to look for three things. The first thing is patterns with a constant rate of change. So you're going to find that there's a number such that you add or subtract that to each consecutive number to get the next one. Patterns with a non-constant rate of change. So in this they have a common ratio, meaning they're going to multiply and or divide, I guess you could say, but like if it's times 3 or times 1/3 or something like that, which would be the same as dividing by a half. And determining patterns from a set of changing shapes or equations. Noticing what changes from one to the next. Oh, and back to this non-constant rate of change. Or some other scheme. So different differences are between each two consecutive terms. So we'll see what that looks like. Table below shows Joe's weekly pay based on the number of pairs of shoes he sells. Well, it looks like that for every 10 pairs of shoes that he sells $620 minus 560 shoes, which is 60. So the difference here, alright, every time he sells 10 shoes, he sells sells 10 pairs of shoes, he gets paid $60 more. And so again, we can check here, and it is also $60 more. So if he sells 50 pairs of shoes a week, what's his weekly pay? Well, the strategy here to make sure you get the correct answer is just to write down the ones that are in between if you don't set up any kind of equation. So for 40 weeks, we're going to add 60. So that's going to be 740. And then for 50 pairs of shoes, we're going to do 60 more, which is 800. Okay, so that's where it has a constant rate of change. Every time the weekly pay goes up $60 when he gets 10 pairs of shoes sold. Look at the pattern below, 5, 10, 20, 40. If this pattern continues, will be the 6th term. So that's another key here. Always look and see what they're asking you to find. It's either going to be a next term, 6th, 7th, 8th, 10th. Just make sure you know, because one of the answer choices will always be something that you're not supposed to find. Alright, so let's take a look here. Well, we can't say that it's constantly adding 5, because then this is not adding 5. Alright, so that's out. If we look, maybe it multiplies something, and it does. So we could say 5 times 2 is 10, times 2, right, is 20, times 2 is 40. Alright, so that's it's a non-constant rate of change, but we can call that a common ratio. So for the 5th term, we've got 40 times 2, which is 80. Alright, so there's 80. And the 6th term, 80 times 2, and 160. So there's our 6th term. We would bubble in 160. And here's a pattern of dots. How many dots would there be in the next diagram of the sequence? Alright, so this is one of those, you have a shape and you have to figure this out. Alright, so term number 1, or figure number 1, has 1 dot. Figure number 2, figure 3, figure 4. Figure 2 has 5 dots. Whoops. Figure number 3 has the original 5 dots here, plus 1, 2, 3, 4 more. So a total of 9. We got the 9 dots from this shape here, plus 1, 2. Let me just circle this so you know. 1, 2, 3, 4 more. Because this shape is the same as that shape. This shape is the same as the previous shape there. So that's 9 dots we already know, plus 1, 2, 3, 4 more. That's 13. So this has a constant rate of change. Plus 4, plus 4, plus 4. And it says next. So not 6th or 10th or whatever, it's next. So the next one would just be 13 plus 4 for 17. Alright, and really quick I'm going to address one of those other ones here. If I have a sequence that goes 2, 5, 10, 17, 26. Alright, notice that we have a plus 3, then plus 5, plus 7 here, and plus 9. So there is a pattern. It's not constant. You wouldn't call it a common ratio either. So you can understand that the next terms can be figured out as long as you keep increasing in the manner of the pattern. So like to get the next term here would be plus 11 for this one, and then plus 13 for this one, and then plus 15, and so on and so forth. Alright, so good luck with the sequences.